Hi everyone, retro gamers, tricky trekkers, and old school coding enthusiasts. I'm making this video because I learned recently that, contrary to what I believed initially, the first Star Trek video game was not the arcade one from 1983, but a way older one from 1971, which been coded by Mike Mayfield in the basic programming language for a Sigma 7 mainframe computer. And I found a way to play at it, and I'm gonna show you that in a few minutes. So that game were adapted by Mike Mayfield to run on a HP 2000C mini computer in 1972, so 1 year after. And following that, it got included in the HP software catalog, and from there it spread and a lot of people, relatively to the time, a lot of people began to play at it, and as as you may know, Basic had very different versions of the programming language, uh, based on the brand of the various computer. So people had to adapt it to work on their own, and a lot of people made a change in the game on the way to improve it, etc. So a lot of variants of the game got made. Then one in particular was made by Bob Lidom, who changed so many things in the game that got named Super Star Trek, and that version of the game went very, very popular among computer owners in the 70s, and that version of the game got published notably in a book, and from there a lot of people and companies made other variants of the game and improved it in their own ways. And there are a lot of variations of Super Star Trek got made up until the 80s. But what I wanted was to play to the Mike Mayfield one, the first one, the first version of the game. So I found like I said before, I found a way to do it. I had to adapt it because the code I got, which is easily found on the web, is the basic code in HP Team Shell Basic, and modern interpreters don't understand that language. So I found a basic interpreter who works on most actual computers, called Vintage Basic, and I had to adapt the code. But I'm not gonna go deeply in it right now. So because the next part of the video will be in in three parts. It's a terrible way to say it. Okay, I'm sorry, English is not my native language. So yeah, the following of the video will be in two parts. So first I'm gonna show you the game. Then maybe you want to play it after having watched how it goes. So I'm gonna explain to you how to install it on your computer and run it. Then the last part of the video will be where we will dive more into the coding aspect of the game, and I'm gonna explain how I had to adapt the code from 1972 into a code that the Vintage Basic interpreter could understand. So that's it. So here we are. Let's go for a little demo of the game. So I'm launching the game in command line because I don't know, it feels more authentic. But in fact, I'll explain it to you afterwards. But you can just launch it with by double-clicking an icon like any other game. But yeah, as it is a game that's played by entering commands, it felt more natural to me to launch it by command line. So here we are. It's the title screen. Wonderful, right? So yes, I'm gonna display the instructions. So I'm not gonna go into details here because I will explain along the game. So after the instructions, the game begins by a first short-range sensor scan, which is here. The result is here. I'm gonna explain that later, but just for you to know, the short-range sensor scan display everything that is in a quadrant and the positions. And here the meaning of every characters or characters group. So we know what is the Enterprise, Klingon, etc. To move, the game uses the command 0, which is the warp engine control, and it's required to input directions, which are a number between 1 and 8, and it's varies what each number means as vectors. Then thereafter the game asks for a warp factor, and a warp factor is that a warp factor of 1 is the size of 1 quadrant. So if you want to move by 2 quadrants, you need to enter a warp factor of 2, for example. But we'll see that. But yeah, I wanted to emphasize the importance of that schema, because well, it's always needed to know what the vector directions stands for. So I highly advise to put it and to copy paste it somewhere, or to draw it in a sheet of paper, because it's easily forget and there is no way to display it again in the game. So here we are the objective of the game. So the idea is that the Klingons invaded the Federation, and we need to fight back to stop the invasion. So now we have to destroy 21 Klingon ships in 30 stardates with 3 starbase. Those values are random, so some instances of the game are harder than others. And well, let's begin. So I'm gonna raise shield before I forgot, because if we our shields are at 0 and we are shot at, well, the Enterprise is destroyed. So you see, yeah, the short-range sensor scan display more data than only the position of the element in the quadrant we are in. So there is the start date, the condition. It becomes red when we have Klingons in the quadrant. The coordinates of the quadrant and of the sector. So a sector is in a quadrant. It's 3 character large and 1 character high. So yeah, the numbers of about sectors not really useful because well, there is no numbers around to help us. I think it has been added in Super Star Trek, but not in the original one. The amount of energy units available in the ship. So when we raise the shield, what I did was to reallocate a number of units to the shields, and the number of photon torpedoes we have. We start with 10. If we spend all our energy, the we lose, and energy is required to move and to shields, and also to fire phasers. We'll see that later. Hop. I'm sorry for the cut in the video, but I had to relaunch the game because last time I mistakenly cut my microphone off. So I was explaining things about the game and it was not recorded, so that's bad. But here I am again. So let's do a long-range sensor scan. So what does those numbers mean? Each number here, like this one or this one, is display a quadrant. So we are in the middle quadrant here, and those are the surrounding ones. So in each quadrant, the unit digits is show the number of stars in the quadrant. So we are in a quadrant with 5 stars, as you can see in the short-range sensor scans. The 10th digit is shows the number of space stations in the quadrant. So there are no space stations in our immediate vicinity. And the 100th digit shows the number of Klingon ships in the quadrant. So now we can tell that there is a Klingon ship on the quadrant on our left side. Okay. There is oh, I forgot to mention that when you type 9, you see a list of commands. So that's every command we can type. So they are available in the instructions, but if you don't want to scroll all the way up each time you forgot what number stands for what instruction, you have a reminder here. And that's the same thing when we use the library computer. We can see the available functions of the library computer. And I will show you that one, the cumulative galactic record. So it's it shows the galaxy we are in, and yeah, so there is 64 quadrants in the galaxy. Don't ask me why. I know in the shows it's not the same. There are only 4, but that's how the game is made. So there are a lot of 0 here. That's because there are quadrants we haven't scanned yet. So it shows only an history of the long-range sensor scans. That's why we have only those quadrants where there are indications, because it corresponds to the only long-range sensor scan we did. So there will be more and more information here along the game and the scans we made. Okay, Anna's talking. We'll start to fight Klingons. So I can't move to the quadrants on my left because there is a star in the way, and I can't go through star. That's why I will firstly move a little bit inside the quadrants before going out. Okay, now the path is clear. Okay. Oh, so what that stands for is that during the move, the long-range sensors went damaged, but the engineers are miracle worker and they repaired it fast, so they are still available. But sometimes it's not the case, and in fact, well, I show you the damage control report here. So here is a list of every device on the ship that can be damaged in the state of repair. So 0 states that it's just good as new. There were no previous damages and no repairs made. Number above 0 mean it has been damaged, but it has been repaired thereafter. And under 0, it means that it's damaged and that we can't use it. And it's in the it's being repaired in the process of repairing. What can I say? Yeah, the damage control report can be damaged too. So there are some times where we don't even know what's damaged or not because the damage control report is not available to use. There is another command that shows the damage control report is the status reports of the library computer. So it shows where we are in the game, number of stardates left, number of Klingon left. Why there is a counter for star bases? It's because we can destroy them by mistake if we misfire a photon torpedo, for example. The starbase can be destroyed. So better be careful around starbases. Okay, so let's fight that Klingon. I will use photon torpedoes. We have only 10 of them, but they have many advantages. So, for instance, they destroy any Klingon ship they touch. So we have to input a vector like the one we use to move, and they can't fire back when we throw photon torpedo. They are either destroyed or not. If they are not, they fire back, but if they are destroyed, they can't. That's not the case with phasers. If we destroy an enemy with enough firepower of phasers, they still have the time to counterattack before being destroyed. Okay, no Klingons around. So we are here, and I will see what we can explore right now. Yeah, we are going to go there. We couldn't go there also, so we could scan a large unexplored territory. But I don't know, it feels more interesting to go there first. But that's up to each their own, I guess. No stars in the way. Okay, good. There's a starbase nearby. I don't really need to use one now because well, we have still most of our energy and most of our photon torpedoes. That's what they are used to recharge. So yeah, now I will go there. So we are here. 1, 2, 5. No stars in the way. Oh, Klingons. And another starbase nearby. And another Klingon also. Okay. Yeah. That's good because we've scanned all those columns. Now we know what to do here. So Klingons, my shares are raised. I could have guessed the trajectory of the torpedo to throw at that one, but this one is harder to guess, so I will use a pretty useful command of the computer here. So it shows the direction of each Klingon ship in the quadrant to fire photon torpedo at. That's pretty useful. So I just have to copy what's written. Okay. But if there are stars in the way, it won't tell us. We have to visually check that because photon torpedoes can't go through stars. Oh yeah, I didn't told about that, but when I used that command, it asked me if I wanted to use the calculator, and I say no. The calculator is something other that allow to calculate trajectories, but we will find a good usage of that later in the game. You'll see. Okay, the star may or may not be in the way. It's a bit blurry, but I will try it anyway. There is a space station nearby, so it's not really an issue to waste a photon torpedo if it's the case. Oh, good. Good. The star was not in the way. So no more Klingons here. We are here. I will go there, I think. No, there. So we can scan all those things, because this one here has not been scanned. There is always at least one star in a quadrant. There are no empty quadrants in the galaxy. There are empty quadrants outside of the galaxy here. So if we go there, there will be nothing. But yeah, but nothing. I just tell what I wanted to tell. So, well, I will use that famous calculator. It's a good time to show you. So, the calculator is a tool to calculate trajectories between two sets of coordinates. So if I hypothetically want to calculate a trajectory from the quadrant 1,7 to the quadrant 4,3, I can use it, but I failed to see the usefulness of it. So it reminds us our current coordinates. So I will enter this, and I will enter the coordinates of the quadrant I want to go. So it will be 2, 5, and it will tell me what do I have to enter in the warp engine control system to make the move. You don't take stars in account, so it may be an issue. But we'll see. So to enter coordinates, it is required to enter them one by one digit by one digit. So I can't write that, for example. What I need to do is type the first digit of the first set of coordinates, then the second one. Okay, and now I can enter the first digit of the quadrant where I want to go, 2 and 5. And behold the result of the calculation. So 8, 5. I fear that the star here will be in the way. Not necessary, but yeah, I don't know. Let's try. So if it fails, you'll see what happens when there is a star in the way. Oh, we've gone probably between the stars. That's a good thing. Oh, that's not what I wanted to enter. Okay. So good. We scanned everything here, and we found the Klingon. So let's move here. Okay. I think that the star will be an issue here. Okay, no, it is not anymore. We found a new starbase. We will go to dock here now. Not because we don't have enough energy, but we launched four photon torpedoes, so it's a good thing to recharge. But the main reason is that way I will be able to scan those quadrants and complete those lines. And well, if we are in the same quadrant as a starbase, why not going to dock here? Oh, that's cute. The starbase in the corner. Okay. Now we are docked. Now we can see what happened when we dock to a starbase. So the shields are dropped. So we have to take care of not forgetting to raise them up again when we leave the starbase. The energy is back to the maximum, and same with the photon torpedoes. Good, we have Klingons under there. We will come and fight. So, do not forget to raise shield, and we are ready to move. I will not use the calculator this time, and I'll risk an educated guess on the trajectory of the photon torpedo. Yes. Good, good. So, where are we? Ooh, more Klingon ships. Let's watch the status reports. 8 left. Okay. Good, good. Yeah, okay. I move to the bottom. Hello there. Those one are easy to guess. First one is 6, and the second one is 7. Easy peasy. Okay. I have to move to not for the star to not be in my trajectory, and after I will attack the other Klingons. So at first I will move like that. Okay. Then okay. Ooh. We got lucky here. Photon tubes got damaged along the way, but got repaired fast enough. So, okay. They are ready to get our photon torpedoes. That was easy. Perfectly aligned. Just launched 2 in the same direction and the victory is ours. Oh, more Klingons here? Interesting. We are in 4-6 as stated here. Okay. Okay. And how many Klingons are left? 4. Okay. So victory for the Federation is near. Oh. That's a bit... that's what I thought about last time. Damage control is damage. So I can't know what's damage or not, aside for damage control, obviously. So I hope the photon tubes are okay. Let's see this. Oh, yes. Good. We are good. Okay. The second one hit us hard while we were destroying the first one. So now we are here. I think it might be a good idea to scan from here. So there are a lot of uncharted territory here that we can discover. So I say right here. We only have 3 photon torpedoes left, but there are also only 2 Klingon ship left, I think. Yes, that's right. It was an easy game. A lot of time the game is harder than that, but that's good because that way the video will be not too long. Okay. So I know where one of them is. Let's go. Okay. For the last one, we will fight him with the phasers. So, because I'm not even sure we did one fight with the phasers yet. It will be a shame if we don't see how it goes. So we are in 8.5 and I will use the calculator to set a trajectory to 7.7. Okay. And we found our last Klingon. And we scanned almost... Yeah, we scanned everything. He was in the corner. That's funny. Oh, there is a starbase nearby. No, I don't think we need... Yeah, no. I just put back our shields to 1000 of energy units, and let's go. Okay. I will approach the enemy, so I think being nearer to them give us a better chance of dealing a large amount of damages with the phasers. Okay. Now let's fire phasers. So while we moved, he attacked us with its disruptors. So we got some damage, but I think things will be okay. Oh, that was a really good shot. So as you can see, when we fire phasers, they fire too. We took some damages, but we gave them more, so that's good. I will increase. Oh yes, we won. So as you can see, we destroyed them. We dealt far more damages than needed to do so. But they still had time to fire back. But that's not important now because we destroyed the last Klingon invader. So the galaxy, the Federation is saved. Okay, so this is what is called the efficiency rating. It's some kind of high score, I guess, and it tells us that our actual time of mission was 0 minutes. That's I need to explain that to you. It's normally in the HP Team Child basic version of the game, which was used on the HP 2000C computer. There were a function which allowed developers to get the local time of the computer, and so it was in the game. It was taken as a beginning, then at the end, and by comparing the two, it was possible to know the time someone had spent on the game, and it was displayed in minutes. But Vintage Basic don't have such function, so I was unable to do the same thing. I talked about displaying star dates instead of minutes here because star dates have no relation to real time. They just increase when we move. So I could have counted that and displayed it, but I wanted the game to be as close as possible to the real one, so it was displaying minutes, and even if I can't calculate them, I still display minutes, and I think it's somehow more honest to show that it's one thing that couldn't be translated, so it's 0 minutes every time. Okay, I hope you enjoyed this little demo. Now we will go to the next part of the video, which is how to play the game, because hopefully seeing it in action give you the urge to play at it. So I am using the French version of the video to show you. So it will be the same, but in English in the description of the current video you are watching now. So I put a link in the description to Miga. So all you have to do is to download it. Okay. It's a very tiny file. You see, only 17 kilobytes. Yeah, I think you say bytes in English. And you have to unzip it with any compressing program you may have, WinZip, 7-zip, anyway. In here you have 4 files, so this is just some talk about the thing in case someone shares a link and people saw it without the video. So I explain things that I am currently explaining to you, so you don't have to read it now, but you can if you want. There are 2 files in .bas. So this is the French version of the game because I translated it in French for my fellow French-speaking people, and this is the English version. So that's the one you'll want to launch. To execute it, you'll need Vintage Basic. So again, in the description of the video, I put a link to download the Vintage Basic interpreter. So it works for every main OS you see, for Windows, Mac OS, Linux, and there are explanations on how to install it. And this is what will interpret the source code you just downloaded. So I'm not gonna demonstrate it because it's different for each OS. Then afterwards, you'll just have to double click on the icon once it is installed. And as you can see, command line starts and you can play. And that's it. It's that simple. Now we're going to speak about the source code. So here we are on the website of a gentleman called Dra'ghoH, which shares the first some on the web, to my knowledge, the source code of the game of Mike Mayfield. But the first link he gave on that website was a hand copy from scanned images of the original Mike Mayfield code, which has been restored and corrected by Dra'ghoH. So afterwards he shared another link here, which is, oh, that's not what I expected. Oh, it's here anyway. Here, so it's like it said, it's a code directly extract from an original machine readable copy of the HP library tape. So it's really the code purely as it were saved on that tape. So it's been made by BitTurbo, and that's the code where I took the things from. Let's go there. So on the left we have the code we've just seen, the one extracted by BitTurbo from the library tape. And in the right we have the code, the vintage basic code I made from that original code. So there are some. We are gonna go through the differences between them, and I explain why they are here and what they mean. So the first one is I removed that command here because it's not one of the original commands. It has been added after the extraction to just to keep track of who did it. But the issue is it's not a numbered line, as you may or may not know in basic programming language. Every line is numbered, and the numbers are part of the code. It's not like the ones my editor had here. So I had to remove it, but I did not want to remove it completely. I want for it to still be readable even in my code, because I without that gentleman I would never have the chance to adapt that code into Vintage Basic. So I had to keep paying credit to his work. So what I did was to move it and to make it in uppercase, and to display it in the way Mike Mayfield displays his commands. And I allowed myself to take credit for the adaptation here. And that's all. So after that, there is the first issue I show after the issue of the comment here, is that in HP timeshared basic you can access arrays with brackets like that, or with parentheses. But Vintage Basic can't understand brackets, it only understands parentheses. So I just had to replace all brackets by parentheses. So search and replace is really a good tool for that kind of issues. After that there is here, so HP timeshare basic allow to assign a value to multiple vars at the same time, which can't be done with Vintage Basic. So I had to decompose those multiple assignments into regular one line, one var by one var assignment. So that's what I did a few times here. Like here, there was a lot. Here we have something that I really had to dig in the manual of HP timeshare basic to understand what it meant. So mat is a keyword that allows to use an array as like if it was a matrix, and there is something that fill a matrix with zeros. So there is absolutely no equivalent to that in Vintage Basic. So what I did was a simple for loop. So here's the colon in Vintage Basic and probably other brand of Basic, I don't know, allow to stack multiple line of instructions in one same line. So that allowed me to save space in case I had to add more line of code here. And the other time I came across that kind of issue. After that, there is something a bit weird because it's the only place where Mike Mayfield labels like that. So he stacked together various labels in the same string vars or array vars, where two. And later on, when he need to access those labels, he access those strings like if it were arrays, which is something that is allowed by HP Time Shared Basic, but not by Vintage Basic. So either I had to change the way those labels were accessed everywhere in the code where they are needed, or I could change the way they are declared, and that's what I did. So I put each label in a proper array place, and those ones are the values that when it tried to access those labels, it as if there were arrays. That's the number that are used. So everywhere in the code, I didn't have to change anything about the accessing of those labels because the declaration were consistent with the way it was accessed. That's how I found my way here. I skip every part where everything is okay, or where I've already explained. So this is something about screen concatenation. So in HP Time Shared Basic, it seems that either no concatenation operator or a semicolon means the same thing. Oh no, yeah, no, sorry. When there are no operator, the string are concatenated with a space in between. So when it's displayed in theory, it's right. It's you must destroy space, the value of k9, and the following of the string. But that's not how Vintage Basic handle things. In Vintage Basic, there are two operators to concat strings and vars. There is the semicolon and there is a comma. And the comma do something which resemble tabulation, and that's not what we wanted to use. But if there are no operators to explicitly convey the concatenation, Vintage Basic treat it as if it were a comma. So that's not what we want, so I replaced my semicolons with just stick the two parts together without adding anything. That's why I added a space at the end of each string here. So, oh yeah, there is something weird. So the Z dollar here is a string filled with spaces, and the weird thing is Q, R, and S are arrays. So I don't really know how HP Time Shared Basic handles this normally, but what seems to happen, given what I saw later in the code and what is expected to happen, it's that it filled the arrays with strings composed of 3 spaces. So I don't know how it's supposed to work in HP Time Shared Basic, but given what was expected by the return code, I just did it with for loops because Vintage Basic just doesn't understand trying to assign a string into an array directly. So yeah, so I did those for loops to fill the arrays with 3 spaces strings. Next to that, there is another issue, and on that part, I think that HP timeshared basic is more logical in this way to answer that. So what's happening is that the key3 statement here, the key3 var, sorry, can be inferior to 1, and when it happens, HP timeshared basic come here and just skip the for loop to the next, to what's after the next. But Vintage Basic doesn't check the first time it enters the for loop. It just enters the loop, and it checked afterwards, after the next statement came back to the loop. So the issue is that the Vintage Basic interpreter were executing those lines when it shouldn't have. So to prevent this, I added that if here to skip the if, the for loop if key3 is inferior or equal to 0. That's why. So yeah, key3 is an integer, so there is no risk of it to be somewhere between 0 and 1. Here is something which was for once it was easy to understand, and it's just a difference in syntax. So it's basically the same thing and do the same thing. It's just that Vintage Basics use that syntax. That line is very important because that's what dispatch the command input by user to the good part of the code, to the corresponding part of the code. So yeah, it's like an ancestor of a switch in a way. Oh, here we are. So we are coming across the layout thing, but I'm not. I will not use this line as an example because there is one that's easier to explain. Here, that one. Yeah. So HP timeshared basic have a system of layouts. So what we can do is declare a layout with that image keyword, and so it's basically concatenations of strings and vars which are all named D. And what's happening is whenever we want to use that layout with the variable we have at the time, we can use we can take use a print and add the keyword using and the line number of the pattern, the layout, and afterwards just add whatever vars we want to add in the order of the D here. So we know that the first var here, whatever it is, will go in the first D, and the second in the second D, and if there are 10 D, the 10th var will go in the 10th D, etc. So it doesn't exist in Vintage Basic. There is no equivalent to that. So what I did was just taking the layout and putting directly in the print, and doing copy paste when they are used in multiple places, and just replacing the D with the inputted vars, and that's it. There are some subtleties in it, but we will see it soon. Yeah, very soon, because they are here. So there is some kind of particular syntax to layouts in HP Timeshared Basic. So, for instance, a number followed directly by parentheses means that whatever is inside the parentheses will be repeated the multiple times corresponding to the number. So this means that this will be repeated 3 times, for example. So I entered it in a very lazy way. I just copy pasted 3 times the thing. I could have used for loop, but I did not. Well, maybe not. But why? Well, for just 3 copy paste, it was easier for my laziest to handle that. And there is another thing: is one can add a number before the one of the D vars, even if there are multiple ones, and it means that that var must be displayed in 3 characters, no more, no less. So if there are more, they are just cut it out, and if there are less, the place is filled with spaces. And there is an equivalent to that in Vintage Basic, which are the right and left statements that permit to do the thing. And just I had to use str statement to convert the vars into strings, because the layout does it automatically, but not here. So it's no issue, because the print will convert them, but to right and left are functions that can only be used on strings, so I needed them to be converted to string before. And there is a plus 1000, and I had a very good reason to do it, but I totally forgot why, so I'm sorry, I can't explain right now. But yeah, I don't think it will be really insightful, so just continue. Let's see if there's still interesting thing to show. There are, but I don't know if there are far. Oh, that's not a big thing, but Mike Mayfield used that layout functionality with numbers and the var to also convert floats into integers, even if there is a int function in HP Timeshared Basic, but somehow it probably was easy to him to use that layout syntax to do it. So when it was logical to do so, I used int statements instead of write to do the same thing. because it felt more. Well, the result is the same anyway, but I think it's more logical to do it that way. Okay, so I'm continuing. Oh yes, here is the part that made me scratch my head and tear out my hair. No, not that much, but I had a bit of. Oh, I forgot that. Yeah, before that, just HP time shell basic in print allow to add special chars into strings by using that syntax. So anti-slash, then the number in the ASCII table of the special char. But Vintage Basic doesn't understand that. It just leave it as it is and output it like if it was just part of the string. So I check it out, and it's just a return. So I use it prints, empty prints to make returns, and it does the same thing. So yeah, H8, the thing that's weird. So what's happening here? I will explain because it's interesting. And so this is the command line. Well, when you use a library computer to and photon torpedo data, that's the code which is executed at that time. So H8 is initialized here at 0. Then we enter a for loop from 1 to 3 because in a quadrant there can be from 0 to 3 Klingon ships. And if there are Klingon ships, it will calculate the coordinates for each one of them. And afterward, near the end of the loop, it checks if H8 is equal to 1, which it isn't because there are only two places where H8 have assignments, is when it's initialized at 0 here, and where it's assigned to 0 again here, which makes no sense because it's already to 0, but anyway, so H8 is not equal to 1, never, ever. So the loop continues until the end of the loop. Then H8, so like I said, is again assigned to 0. It asks if the user wants to use a calculator, and if the user say yes, there is a go-to to somewhere inside the for. In the calculation column are displayed, we come again here. H8 is still at 0, so we never skip to there. And what happened here is that the interpreter comes to a next of a for loop that is long gone from his point of view, and even better, it's not even in its buffer memory because the if were ended, so it was not required anymore to keep in mind, as I can say, and it just crashed. It's I don't understand there is a next without a for, and that's because the go to here don't go up to the for here. You just stop and go in those lines. And yeah, and that's weird because clearly that statement is meant to prevent this. Because even if there were no no crash because of the next here. There will be an issue with a loop where the user is constantly asked to if you want to use the calculator, as long as it doesn't say no, which would have been weird. So when I saw that, I just tried to put 1 to H8 here, because it feels somehow logical, because now when we exit the loop, we know we have entered it and then exited it. So when we go back in, well, we just skip and go to the lane where we ask a new command to the user. But the issue is that I wanted to play the first version of this Star Trek game, and somehow in that version H8 is never assigned to 1, so it's supposed to crash. So was I changing the code for it to fix the issue, or let it as it is with that issue? It was, yeah, a big dilemma for me. But I ended by changing it, and here is my reasoning. So, firstly, it's a big crash that we can keep playing the game after that. We have to restart a new game, and it's a bit harsh for the player, really. If it were a bug that was just doing something weird or funny or whatever, but still allow the player to continue the game, I would have left it. But here it's just like losing. Oh, you wanted to use a calculator? Oh no, you lose. It's really hard, I think. So that was the first thing. And the other thing is everything in the code, like I showed to you, it gives me the sense that that's what Mike Mayfield intended with it, because everything is there. That if was already there, the initialization was already here, and there is, even if it's not assigned to the good value, it is assigned to value here, and like we saw, it can be nothing else than 1 if we want to stay logical, and if you want to, for each statement to make sense in that code. So to me, that's what Mike Mayfield wanted to do, or even he did, but somehow on that tape the value was not the good one. But, well, now you know everything. If you think that it should be kept at 0 here, you can change it, because well, when you want to play it, you'll have the source code of my adaptation, so feel free to do what you want with it. But yeah, you have my reasoning and why I did the thing the way I did. And after that hard part, we have finished reviewing the code. So I hope you find that interesting and you enjoyed watching that video. If you came this far, I thank you for watching it in its whole entirety. And well, I will give you a traditional salute for Trek fans. So live long and prosper.